Hello, everybody. Welcome to my presentation about Xen hypervisor file system. My name is Jürgen. I'm working at SUSE, responsible for Xen, mainly the kernel parts, but I'm doing a lot of hypervisor work as well. So what we will cover today is a brief overview about the design of the hypervisor file system, so what it is meant for, what is the current status in Xen 4.14, what are the plans for the next release, and some ideas what else could be added to Xen hypervisor file system. Maybe there are some ideas from the audience as well. And if there's enough interest in this topic, we might want to add a design session for further use cases. Just a small remark, if there are any questions, you can just ask them right in between and I will try to answer them or postpone them until later as it comes. So what is the main motivation of doing something like the Xen hypervisor file system? There have been several requests in the past for obtaining special data from the hypervisor. There were some requests for obtaining the .config file, which was used for building the hypervisor, or for retrieving runtime parameter settings. Those were raised by customers of SUSE. So, for example, the config file contains interesting information like for how many CPUs was the hypervisor configured, is memory above 5 terabytes or 60 terabytes supported, is any special feature available in the hypervisor or has it been compiled away? So this is rather interesting. Additionally, I have tried to upstream several patches, like setting per domain or per CPU pool parameters. And doing this via syscontrol hypercall were not regarded as to be the right way to do it, because there's a lot of user supplied value parsing done in the hypervisor this way. The same reason was that some generic extension of log profiling I've tried to upstream was not accepted. I wanted to debug my core scheduling patches and enhance log profiling a little bit, but the additions again were rejected for being too special cased parsing again. A general desire has come up to get rid of as many unstable hypervisor interfaces as possible. Those unstable interfaces, those are mainly syscontrol and domain control hypervisor calls used by the Xen tool stack. Those are a problem when you're updating Xen to a new version and don't want to have long downtimes. You normally do it on a running server. But when there are guests running at the same time, you get new hypervisor and new tools installed. The hypervisor, of course, is only put into a file which can be booted later, but the tools will become effective from the next call on. So you then have new tools running on an old hypervisor, which might not understand each other. So when you're upgrading Xen, you might end up with a situation where you can't control your running guests any longer. So getting rid of the unstable hypervisor interfaces is a nice thing. And there are a lot of unstable interfaces which are rarely used, but when used, they should work, of course. So how does the hypervisor file system look like? It's basically similar to Linux kernel sys file system. So the idea is to have directories and nodes filled with dynamically by the hypervisor according to the situation. We have a stable library in userland, libxen-hypfs, for accessing the hypervisor file system from userland. So this is a way to access this file system from a program. And of course, there's a little program called xen-hypfs used, which is using this library to access the file system from shell or from scripts. Right now, it's usable from DOM0 only, in spite of having, when you compile xen with XSM enabled, you're able to allow xen-hypfs access from other domains as well, but this is not a very common configuration. So here are some examples. So the xen-hypfs tool can be used to output the complete tree of the file system. So you see the root node and all the nodes below it. You can use it to print the contents of a node. In this case, a runtime parameter. So params grant tab max frames will output the normal number, which is saved in this parameter. It's possible to modify that parameter via the write option. In this case, we are writing the value 30. And when printing it again, of course, the 30 has to come out again. So up to 4.13, there was an XL option to write runtime parameters, but you couldn't read them again. So you had to remember what you have written into such a parameter. And now it's possible to read the value again. And you can look at one directory, which entries are there, which type they are, and if you can only read them or read write. In the hypervisor, you have static directories or nodes which can be added very easily via macros and a few lines of code. So for example, for adding a static node, like we've seen here, the compiled by or compile date or something like that, which is static data, which won't change during the runtime of the hypervisor. There you need only one line for the declaration of the node and one line for hooking it into its directory. Each node contains internally hooks for reading and writing that node. There are default functions for that purpose, so you don't have to invent a special function for each node, of course. But if you have special needs, you can just add another function in there to do some special handling, for example, dynamic output or things like that. A node content can have different types. It can be a bool, an integer type of various sizes. It can be a string, or it can be any binary blob. But in case of binary blobs, of course, you need special handling at user side as well. The contents can be encoded, for example, gzip. This is, for example, used for the config files. So like in the kernel, you have proc config.gz. For the hypervisor file system, as the encoding is saved in the node as well, the library can decode it for you. So you don't have to worry about having to pipe it through gzip, but you can just print it via the xenhypfs cat subcommand. So what is the current status of the file system? As I've showed in the tree output before, there's some build time information included in the file system right now. There are the contents of the .config file used to build the hypervisor. This can be configured out. So if this file isn't present, the config file, then you can't get the reason for it theoretically, because it's of course a .config option, but this has been added in order to be able to build a rather small hypervisor, for example, for embedded use cases. It should be noted that the complete hypervisor file system can be configured out. So the whole presentation, of course, is basically valid only for hypervisors where the hypervisor file system is not disabled in the config file. And there are runtime parameters, readable and writable, replacing one syscontrol, the syscontrol set parameter sub-option. It should be noted that runtime parameters are a little bit more complicated to handle in code when they're not some plain types like bool or integer or string. So for custom runtime parameters, and unfortunately, I think all but one or two runtime parameters are custom ones. So you need to add a special function to handle them if you're adding a new custom runtime parameter to the hypervisor. But from the already existing examples, it should be rather straightforward to do that. For making it work, I had some additions or changes in xen-tools as well. So, of course, there's a new library, libxenhypfs. There's a program I mentioned already, the xenhypfs program. And I've modified libxl to use the libxenhypfs library for setting runtime parameters, so dropping the old syscontrol from libxl. And I've dropped the syscontrol from the headers on the hypervisor as well, the set parameter syscontrol. So one small step for disabling unstable interfaces has been done. So what are my plans for Xen 4.15? I would like to add some CPU bug information, so which bugs apply to the currently running CPUs, and what are the current mitigation settings of the hypervisor regarding for each bug. So it's a rather large tree of possibilities here, and when seeing the Xen command line, it's not at all obvious which settings are effective. And all this information is printed by the hypervisor at boot time, but unfortunately, if you are not fast enough to save that information, it is gone when the console buffer of the hypervisor has been overwritten. And in large configurations, this can easily happen before you even get a chance to save the buffer. I would like to add some CPU topology information, just the basic things. So how many sockets, which CPU belongs to which socket, how many threads per CPU core, and things like that. As initially told, I wanted to have per CPU pool parameters, so per CPU pool settings are on my plan to do, especially scheduling granularity, so for being able to control core scheduling at a per CPU pool basis. The hypervisor is basically ready for that. It just has to be hooked up somehow. Same applies to per domain settings. So I would like to be able to control mitigation settings per domain. For example, enable, disable meltdown mitigation for PV DOM use, which might be interesting if you say, I'm trusting a driver domain to behave nicely, so I can disable the Xen page table isolation for that driver domain to boost performance a little bit. I would like to add some debug trace enhancements. I've used debug trace a lot while writing my core scheduling series. And I was really looking into enhancing debug trace, for example, being able to define special traces which will only be printed in case of some special settings, or being able to disable some other traces, so a little bit more fine-grained trace behavior. Because always having to reboot the hypervisor and do it again, it's like quite time-consuming. And the same applies to log profiling, which I mentioned before as well. So I'd like to add the enhancements I did to log profiling via the Xen hypervisor file system, which should be more acceptable than doing it via the syscontrol interface. So what else would be nice to have is replacing some more syscontrol and DOM control interfaces. So maybe even controlling other scheduling parameters via the hypervisor file system, like for credit scheduler, the time slice and things like that. Doing that per CPU pool would be nice, of course. Might be interesting to have more topology information, for example, NUMA nodes and things like that. Maybe even usage information per domain. Or other topology information like PCI topology and stuff like that. We could even replace more syscontrol stuff like the command line, which was used to start Xen. Should be a no-brainer, more or less. But other information which is presented via Excel info might be a candidate as well. And there's a lot of other non-performance critical data which can be replaced using the hypervisor file system. One thing which would be rather nice would be to replace the debug keys, which right now print the debug information to console, which is the reason why it is meant to be not to be used in production environment, because it can affect the timing of the hypervisor, and it's regarded not to be completely safe. And doing this via the hypervisor file system might be the better option. Other stuff Could be CPU hot plugging, things like that, which are handled right now via special tools and via syscontrol interfaces. They should be replaceable with a hypervisor file system as well. What else? I have some vague ideas what could be done in future, which would need some more efforts. Maybe it would be a nice idea to have more fine-grained access control, so making some nodes accessible for guests. I'm not sure if this is needed at all. If yes, we would like, of course, to have something like that. Maybe driver domains could make use of some of the nodes. I'm not sure. So this being the main reason I didn't add it in the initial round of patches. What would really be nice, have some real file system in the Linux kernel, which is presenting the hypervisor file system really as a file system, either via kind of a proxy file system, or maybe integrating it into the sys file system of Linux. This would, of course, make accessing all the nodes much easier. We wouldn't need the XAMPP Hypervisor tool any longer, or only for operating systems not having a thing like sysfs. What would really be cool is having some kind of pipes or something like that for being able to read, for example, trace data, console buffer, and things like that. So more dynamical data, which can block and then later deliver more data. This would enable us to move another bunch of interfaces to the stable ABI. Maybe anybody have any other ideas? For example, do we need an ability to link, to add links like in sysfs? For example, we have some classes of domains we would like to link to the general domain list in the hypervisor file system or things like that. So there's plenty of work to do, plenty what can be done or could be done. And I'd be really interested in collecting more ideas in this regard. So again, if there is interest to discuss those topics, I'd be happy to register a dedicated design session for that. So that's basically what I have. Are there any questions? Okay, the design session is a clear yes. Okay, I will register it later. Anything else?
So one thing very quickly, if you're looking for some feedback, I understand why pipes and links might be interesting. I would suggest that we don't contemplate them until we have found something where it will be a concrete improvement. We shouldn't try and put them in simply because we might want to use them in the future. A lot of this gets very complicated. And if we don't actually need them, it would be it'll probably be better not to have them.
I completely agree. So Roger asked if this file system for domains could be implemented as a fuse module. Maybe. So I'm not very deep into something like that. So if there's someone knowing more than nothing about Fuse, so that's basically my knowledge, you'd be very welcome to look into it. but I think we might want to discuss that more deeply in the design session. What would be interesting to know in this regard is something like SUSE available for BSD, for example, as well. Because this would be then a rather interesting way to do it, because then we wouldn't be limited to Linux, right? Yeah, Google tells me that it's available for Linux, FreeBSD, OpenBSD, NetBSD, and so on. So clear yes. Okay. Roger is even using it on OS X, but I think we don't have a DOM0 based on OS X, right? Okay, thank you very much. I hope you liked the presentation, and we might see us again in the design session.